Hello students, today we will be solving the IB Math A HL May 2025 paper 1 time zone 3 question number 8. You will be getting the solutions for the first 7 questions from this paper and the solutions to the other questions from the other past papers in form of playlists on my channel NS Online Math Tutoring Classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I'm Nilanjana Sanyal. I am an online IB Math A HL level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start to solve the question number 8. The maximum mark is 8. Consider the complex number z1 equal to square root of 3 minus 3i. So part A's question is express z1 in the form of r times e to the power of I theta, where r is greater than 0 and theta is greater than negative pi but is less than or equal to positive pi. It is carrying 3 marks. So part A, first of all, let us find the r, the modulus. So r will be equal to the positive square root of this root 3 whole square plus minus 3 whole square. So this is equal to 3 plus 9, which is equal to square root of 12. Therefore, r is equal to 12 is 4 times 3 and square root of 4 is 2. So, r is equal to 2 square root of 3. Okay. And for the theta, tan theta, I'm not discussing how am I getting tan theta, why I am taking tan theta and all these stuff, because I'm assuming that you know these basics because you have come to solve a question on complex numbers from the past papers. So I assume that you know the basics of complex numbers. Okay. So tan theta equal to negative 3 over square root of 3, which is equal to negative square root of 3. Now we have to find the value of theta, and tan theta is negative in the second quadrant and in the fourth quadrant. So which quadrant will this theta lie? In which quadrant? If we think of this point, if we have this Argand diagram, this is the real axis and this is the imaginary axis. The real part is positive, so it is this part, and imaginary part is negative, so it is this part. So the quadrant will be the fourth quadrant. Theta is an angle from the fourth quadrant. Okay, so we have to get the angle theta value, which is in the fourth quadrant. And if we just ignore this minus sign for a moment and we treat this as tan theta equal to square root of 3 and we assume that theta is an acute angle, then theta value will be equal to pi over 3 or 60 degrees. Okay, tan 60 degrees or tan pi over 3 is square root of 3. So therefore, our okay, let me not write theta because it may be confusing. Tan alpha equal to square root of 3, so alpha equal to pi over 3. So therefore, theta will be equal to 2 pi, because it is from the fourth quadrant, so the expression will be 2 pi minus pi over 3, which is equal to, this is 6 pi over 3 minus pi over 3 is 5 pi over 3. But this is a positive angle. But they have said that theta is greater than negative pi but is less than or equal to positive pi. That means that the angles which are from the first and the second quadrants will be positive angles, and the angles which are from the third and the fourth quadrants should be expressed as negative angles. 0 to negative pi, you are moving in this clockwise direction. Okay, and 0 to positive pi, you are moving in the anti-clockwise direction. Okay, so this 5 pi over 3 should be expressed as a negative number, negative angle rather. So therefore, theta will be equal to negative pi over 3. Okay, because this is the position. If you come along the anti-clockwise direction, it is 5 pi over 3. The total is one revolution, which is 2 pi. So if you come in this clockwise direction, what will be the angle? It will be 2 pi minus 5 pi over 3, which will be equal to and there will be the negative sign in front, of course. It will be equal to negative pi over 3. Okay. So theta is equal to negative pi over 3. Therefore, Z1 is equal to R was 2 square root of 3 e to the power of negative I theta. So negative I pi over 3. Okay. Fine. Consider the complex number Z2 equal to 2 square root of 3 times e to the power of I 5 pi over 6. So it is an angle from the second quadrant. The cube roots of Z2 over Z1 are denoted by U, V and W. So part B's question is find U, V and W. Fine. First of all, let us find what is Z2 over Z1. Z2 over Z1 is equal to 2 square root of 3 and e to the power of I 5 pi over 6 divided by 2 square root of 3 e to the power of negative I pi over 3. These two will be cancelling and it is 5 pi over 6 and minus of minus pi over 3. If we do the rough work over here, 5 pi over 6 minus of minus pi over 3. What is it? This pi over 3 can be written as 2 pi over 6. And minus of minus is plus. 5 plus 2 is 7. So this is equal to e to the power of I 7 pi over 6. Clear? And now we have to get the cube root of this complex number. So cube root of Z2 over Z1 is equal to cube root of e to the power of I 7 pi over 6. And using de Morgan's theorem, it will be e to the power of I 7 pi over 18 because it will be 1/3. Cube root means raised to the power of 1/3. E to the power of I 7 pi over 6 raised to the power of 1 over 3. Okay. So this is I 7 pi over 18. Okay. And this is the first root. What will be the other two roots? We have taken the cube roots. So there will be 3 roots. What will be the other 2 roots? The 3 roots will be equally distributed on this unit circle because the modulus is 1. So this is the unit circle. 1 is also getting cube rooted. Cube root of 1 is 1 because in the modulus will be a real number. So it is the unit circle. The 3 roots will be placed symmetrically on the circumference of the unit circle. And one of them is 7 pi over 18. So the angle between any two, I'm just drawing arbitrarily, I'm drawing one of the roots as this. Maybe another root is this one and third root is this. So the angle between any two consecutive roots will be the same. And the total angle about a point is 2 pi. So the angle between any two consecutive roots will be 2 pi over 3 because there will be 3 such angles. Okay. So if this is the first root, what will be the second root? It will be e to the power of I 7 pi over 18 plus 2 pi over 3. What is that equal to? I have to make the common denominator as 18. So I have to multiply this with 6. And this will be 2 times 6 is 12. 12 plus 7 is 19. Over 18. And the third one will be e to the power of I 19. Now this one is 18 over 18 is pi. So this one is an angle from the third quadrant. I have to express this as a negative angle. I am coming to that part. 19 pi over 18 plus 2 pi over 3. So this is equal to again 12 over 18. 2 pi over 3 can be written as 12 over 18. 12 plus 10 is 22. 22 plus 9 is 31. So e to the power of I 31 pi over 18. Okay. 36 pi over 18 is 2 pi. Okay. So now I have to express these two as negative angles. Okay. So if we think about this one, 19 pi over 18. 18 pi over 18 is this pi. Okay. And 19 pi over 18, so it has, maybe this part is pi over 18. Okay. This hole has been created by the anti-clockwise revolution of the revolving ring. Okay. So we have come to this place. This is the final position of the revolving ray. So angle made is 19 pi over 18. And now I have to express this as a negative angle. That means the position of the revolving ray stays the same. But now I have to consider that the revolving ray was over here initially and it has moved in the clockwise direction to come to this point. So that it has made a negative angle. How to get the corresponding negative angle? I can assume that it has moved through a distance of pi in the clockwise direction. So the angle made is negative pi. Okay. And then it has moved in the clockwise direction through an angle of pi over 18. Through an angle of the small angle pi over 18. So it is negative pi because it has moved in the anti-clockwise direction to create this angle, this small angle. It will be a positive angle. Okay. And negative pi plus pi over 18 is what? Negative pi is negative 18 pi over 18 plus pi over 18 is equal to negative 17 pi over 18. Okay. So this is equal to e to the power of negative I 17 pi over 18. And what about this one? 31 pi over 18. Again, I'm taking this and I'll be considering the positive angle first of all. It has come to this point, means this is 2 pi. Okay. So 2 pi, and that is 36 pi over 18. Okay. But we need 31 pi over 18. So what did it do? The revolving ray, it has come back in the clockwise direction through an angle of 5 pi over 18. Since it is the clockwise direction angle, so it will be negative. Okay. So what is the corresponding negative angle? Now we are seeing that this is the starting point of the revolving ring. For the third quadrant, I had to do this going in the negative direction through an angle of pi and then coming back through an angle of pi over 18. But when it is the fourth quadrant, this is the starting point and this is the final point of the revolving ray, and it is moving in the clockwise direction through an angle of negative 5 pi over 18. So that is all. You don't have to do any calculation for fourth quadrant angles. Okay. So you draw the diagram and it is obvious what will be the corresponding negative angle. So it will be negative I 5 pi over 18. So therefore, the three cube roots of Z2 over Z1 is equal to e to the power of I 7 pi over 18, e to the power of negative I 17 pi over 18, and e to the power of negative I 5 pi over 18. Okay. So this will be the answer for the subpart B. Fine, we have completed solving this question. Thank you for staying with me till the end. Please like and share my video with your friends, and please do not forget to subscribe to my YouTube channel. Your liking, sharing and subscribing will be really helping me a lot. We meet again very soon in our next session. We'll be solving question 9 of the same paper. Till then, bye.